Hey everyone, and welcome back to The Explainer. Today, we're getting into a biological concept that is absolutely fascinating, but honestly, it's kind of terrifying when you really think about it. We all rely on our immune system, right? It's our personal, microscopic bodyguard against an endless stream of threats. But what happens when that perfectly calibrated bodyguard goes rogue and actually turns on us? Well, we get hypersensitivity. I am completely obsessed with how this works, and I cannot wait to decode these microscopic battles that are happening right inside us.
Okay, so here's our roadmap for today. We're going to systematically decode the four distinct classifications of hypersensitivity. We'll start with the foundational idea of when immunity goes overboard. Then we'll move through type 1, immediate reactions, type 2, targeted cell attacks, type 3, immune complex collateral damage, and wrap it all up with type 4, delayed cellular responses. Let's just jump right into section 1, when immunity goes overboard. Because keeping a state of balance is absolutely essential for our survival, we really need to understand what it looks like when that system completely falls out of sync. So first things first, hypersensitivity isn't just some casual medical term for, getting the sniffles or having a mild allergy. It is a very specific biological state. It's an exaggerated or sometimes completely inappropriate immune response to an antigen. And the absolute most crucial part of this definition, the end result, injury to host tissues. The immune system isn't just overreacting, it is actively damaging the very body it was built to protect. Which brings us to a pretty profound question. What actually happens when our ultimate protector becomes the attacker? It's basically a massive biological betrayal. And whether the trigger is some exogenous environmental antigen like pollen or an endogenous part of our own body, that resulting host tissue injury is the common thread linking all forms of hypersensitivity together.
Now, understanding this division is the key to the whole map. The four types of hypersensitivity are basically split into two main camps. Think of the first three, types I, 2, and 3, as using ranged weapons. They're humoral mechanisms, meaning they're driven by free-floating antibodies. But type 4 stands alone. It's hand-to-hand combat, a cell-mediated mechanism driven entirely by T lymphocytes. If you keep that basic division in your head, the rest of this is going to click right into place.
All right, let's hit section 2. Type I, immediate reactions. These are the fast and furious responses of the immune system. When people talk about typical allergies, this is usually exactly what they mean. Let's look at how this rapid reaction actually builds. It acts just like a security system deploying a massive chemical alarm. On your very first exposure to an allergen, your body produces specific IgE antibodies that bind right onto your mast cells and basophils. Then, if you're exposed again, boom, the antigen triggers those bound antibodies. This causes immediate degranulation. Basically, the mast cells literally burst open, releasing these incredibly powerful preformed mediators that instantly cause tissue changes. What's truly wild here is the stark contrast between the two phases of a type 1 reaction. The initial strike happens in seconds to minutes, and that's driven mainly by a massive flood of histamine causing vasodilation and bronchospasm. But, and this is a big but, the body isn't done. A late phase reaction kicks in 24 to 48 hours later. That one is driven by newly formed mediators like leukotrienes, which drag in a whole secondary wave of inflammatory cells.
If we follow this timeline, you can clearly see how a local reaction like, say, inhaling some pollen, brings on acute airway obstruction or hay fever in mere minutes. But in systemic anaphylaxis, like from a bee sting or a penicillin allergy, this rapid timeline can lead to life-threatening circulatory shock in seconds, way before it even settles into that prolonged inflammatory phase a day later. The speed of this is just staggering.
Moving right along to section 3, type 2, targeted cell attacks. So if type 1 was our massive chemical alarm, type 2 is the immune system acting as a highly trained, targeted assassin.
In this type, the hypersensitivity is entirely antibody-dependent. But unlike type 1, here we're dealing with IgG and IgM antibodies, and they are directed against antigens located right on the surface of our own cells or tissues. Sometimes it's an extrinsic antigen, like a drug that's attached itself to a cell, but a lot of the time it's intrinsic. That means the immune system looks at a perfectly normal, healthy host cell, completely mistakenly identifies it as foreign, and just paints a giant target right on its back.
And the immune system executes these targeted attacks in 3 distinct ways. First is complement-mediated cytotoxicity. Think of this as direct demolition.
Antibodies activate complement proteins to directly lyse or basically explode the targeted cell. This is what happens in mismatched blood transfusions. Second, we have antibody-dependent cell-mediated cytotoxicity, where natural killer cells spot that antibody target and sweep in to destroy the cell. And the third one, antibody-mediated cellular dysfunction. This one is crazy. The antibodies don't even destroy the cell, they just hijack its function, like in Graves' disease, where autoantibodies mimic hormones to overstimulate the thyroid, or in myasthenia gravis, where they block nerve transmissions. It's literal biological sabotage. Now let's step into section 4. Type 3, immune complex collateral. If type 2 is a precision sniper, type 3 is a systemic littering problem, and it causes widespread collateral damage. What's happening here is that antigens are binding with antibodies to form actual physical clumps. We call them immune complexes, and they're just floating around in your bloodstream. Normally, the body's pretty good at taking out the trash, but in type 3, these roaming immune clumps get physically wedged into the tiny endothelial pores of your small blood vessels. Once they get stuck, they act like microscopic traffic blockages, activating complement proteins and causing severe tissue necrosis right at the site of the jam. So let's walk through the 3 phases of systemic immune complex disease, also known as serum sickness, just to understand exactly how this catastrophic littering sequence unfolds. Phase 1, the antigen-antibody complexes form in the circulation. Phase 2, these complexes deposit themselves into various tissues and blood vessel walls. And finally, Phase 3, the development of intense inflammatory reactions at all those dispersed sites. This is the exact mechanism that leads to conditions like systemic lupus erythematosus or rheumatoid arthritis, where generalized inflammation is just wreaking havoc across multiple organ systems. All right, we've made it to section 5, type 4, delayed cellular response. As we transition here, I actually want you to slow down your mental timeline a bit, because the mechanics of this final reaction operate at a much, much different pace. Notice the drastic shift in timing. Unlike the immediate, terrifying shock of a type 1 allergic reaction, a type 4 reaction takes a full 24 to 72 hours to even manifest after exposure. Why the big delay? Because this process isn't relying on fast-acting, free-floating antibodies. It requires the physical travel and activation of actual, complex cells. And here is the plot twist we talked about earlier. This type drops the antibodies entirely. It relies exclusively on hand-to-hand combat via T cells, operating in 2 distinct patterns. First, we've got delayed type hypersensitivity. This is where memory T cells spot an antigen and send out chemical distress signals called lymphokines. That pulls in macrophages to destroy the threat. If you've ever had a positive tuberculosis skin test, this is exactly what caused that bump. The second pattern is direct T cell-mediated cytotoxicity. Here, specialized cytotoxic T lymphocytes just take matters into their own hands and directly kill the antigen-bearing cells. This is the heavy-duty mechanism responsible for contact dermatitis, and unfortunately, it's also the main culprit behind organ transplant rejection. So looking at the big picture, we can finally map out how these tiny microscopic errors trigger some major real-world diseases. We see type 1's mast cells causing asthma, we've got type 2's targeted antibodies driving Graves' disease, type 3's complex deposits triggering systemic inflammation like lupus, and type 4's delayed T cells causing graft rejection. It is a complete, fascinating spectrum of immunity gone wrong. And that really leaves us with something incredible to think about. When you consider the sheer destructive power of these 4 hypersensitivity mechanisms, how incredibly delicate is our biological state of balance? Every single day, your immune system is making millions of microscopic decisions, navigating a razor-thin line between being your ultimate protector and a devastating attacker. I really hope this explainer has given you a totally newfound appreciation for the complex battles happening inside you right now. Keep learning, keep questioning, and I will see you in the next explainer.